that's typically what's done. Okay? But actually, that's like the default. You know how we pick out the mode shapes and natural frequencies? Or we did that? That should be in there. I think there's a key where we can say to normalize it. I don't know. I'll look for it. There's a way to normalize it. So when I look at my results, the maximum displacement will be 1. And that's typically what other software packages do. Okay? We're just concerned about the shape. So when we normalize it, everything's going to be normalized. Typically, the largest displacement is going to be 1. All right, so coming over here, it's hard to do any kind of modal analysis without looking at the undeformed shape. So here's my undeformed shape. If I come over here, now I'm going to go ahead and do a right view. There's my first mode. This typically it's going to be normalized, so my maximum displacement would be over here at 1. Come over here. I want to go ahead and animate it. And I want to do full cycle. And this is typically stop. Oh, mode. So when I actually vibrate this ruler, if I come and I pull it and I let go and it's going to vibrate, right? It looks like this. It looks like the first mode. Most everything when we vibrate it, it's displacement. When we're looking at it with our eyes, it's going to look like the first mode. Because all of our energy is in that mode. All of our energy is in that first mode. So that's the first mode. I'm going to come over here. I'm going to go to the next mode. This is our second mode. It's not moving at all. It's vibrating. I can't move it, but it's vibrating back and forth like this, right? So it's like a snake kind of thing. It's vibrating like that. That's how this is vibrating. This is typically that first mode we saw. It was like our first transverse mode, and then this would be a longitudinal mode. So our first longitudinal mode, our first transverse mode. Then we go to the next one. This is our second bending mode. Now I know this. I know what frequency this is at, right? Everybody nodding? I know exactly what frequency this is at. I know exactly what that mode shape looks like, right? I can take this ruler and I can come over here and I can fix that little point right there. I can take this midsection, I can bend it up a little bit, and I can release it. Guess what this is going to look like? It's going to look exactly like that. For simple structures like this, I can force it to vibrate in that mode. Okay? So all our modes are important. When we're looking at something, when something's vibrating, now typically when we go to something like our 5th mode, 6th mode, it's going to be almost impossible to vibrate it in that mode. Okay? But I can make something vibrate in this second mode shape. So that, again, if I'm sitting there on the tarmac with my jet engine going, do I want to be close to the second mode of vibration? No. Okay. No. Now, we see how the displacement is, right? So it's going to be hard. It's easy to get our turbine blade to vibrate like this, right? Back and forth like this. It's much more difficult to get it to do like this. So it's not, I mean, the chances of it happening, even if we're sitting there at that frequency, you know, it's probably not going to happen, but it's still a possibility. Because we have to make it look like that. Okay? So I can come over here and I can kind of hold it right here and I can move up the middle section and I can release it and it's gonna vibrate just like that. Okay? And that is the natural frequency, whatever I get right here. So 1,112 hertz, that's the frequency is going to be vibrating at. Now I'm going to go to that's my 3rd mode, right? Where is that? Mode 3. Now I'm going to go to my 4th mode. What's this besides my stuff? It's like that bridge. It's called a torsional mode. So this is my first torsional mode of vibration. It's just twisting. Okay? Now notice when I came over here and I pulled this down and I let go and it started vibrates like this. If I want to see these modes, am I going to see this if I come over here and go to the center of my beam and let go? No, it's not. If I want to see this mode, I actually need to kind of excite it to get in that twisting mode. So if I actually pulled down on the corner of this and released it, I would probably see the torsional mode. Now, if I put accelerometers along the center, am I going to see anything? No. Okay? So a lot of mobile analysis tells us where I want to put my accelerometers. If this is the second mode, right? Third mode, but second mode of longitudinal vibration, right? So do I want to put accelerometer right there? No. Okay. I don't want to put accelerometer there because I'm not getting any energy from that second mode there. So it's not going to help me. It's going to put more errors into my approximation of the mode shapes and natural frequencies if I put accelerometer there. All right, so that's that. There's the first torsional mode. This is our second lateral bending mode. What is this? That's like our third torsional mode, right? What the hell is that? I only say that first, just make fun of me. What do you mean that? What is it? A what? Compression? Tension. Well, when it's bending like this, you're saying I don't have any compression or tension? What about temperature? Why the heck is that? It's axial! Thank you! It's along the axis of the beam, right? So this is our first axial vibration mode. This is the simplest model when we went to beams, right? Remember when we did 1D, our stick models, and we were doing examples up here on the board? That's our first axial vibration is first order. Okay? It's a very first order differential equation, very simple to solve. Okay? That's vibrating along the axis. Okay? That's what we typically find. So this is our axial vibration mode. It's just moving along the axis. So like an accordion, right? All right, plenty of curves of that. And we see all of these. So I already lost count of bending modes. That's our second torsional mode. And then that's it. That's our first one. So modal analysis is a big part of finite analysis. We get a tremendous amount of information doing modal analysis inside of our vibration software. Any questions? Nope. All right. Sorry.